Hello everyone, and welcome to 7th grade Math Module 6, Geometry. In this video, we're looking at Lesson 11, Conditions on Measurements that Determine a Triangle. Our learning goal is to make sure we can use the triangle inequality theorem and the triangle sum theorem to determine conditions that would form a triangle. This will help us to master Standard 7GA2. Draw geometric shapes with given conditions. Focus on constructing triangles from 3 measures of angles or sides, noticing when the conditions determine a unique triangle, more than one triangle, or no triangle. The first condition that we're going to talk about today is the angle sum theorem. And the triangle sum theorem states that all of the measures of the inside of our triangle will add up to 180 degrees. So if I just take the measures of those 3 angles inside and add them, they have to equal exactly 180, not 179, not 181. So if I have 3 angles and I want to see if it would make a triangle, I just add them, and if they make 180, I'm good. And if I have 2 angles and I'm trying to find the third, I can add together the 2 I know and subtract them from 180 to find what the third would be. So let's say we have the triangle on the left here and we're trying to find the missing angle inside of our triangle. Since I know from my triangle sum theorem that if I add my angles together I will get 180, I can start by writing an equation where the 3 angles that I have are added together to equal 180. Then I just need to follow my algebra problem solving steps to find out what my missing angle is. So I could combine like terms with my 38 degrees and my 27 degrees, and then I'm left with 65 degrees there. So then all I need to do is my inverse operation, taking that 65 away from 180 degrees to find out that my missing angle is 115 degrees. You can pause the video here and try to find the missing angle in the triangle on the right. How did it go? To start off, you should have written an equation by adding together all of the angles that you knew and the variable for the missing one and setting that equal to 180. Then you combine like terms, getting 146 degrees plus f equals 180. And then undo your operation there with the inverse, so addition with subtraction. And that leaves us with the measure of angle f being 34 degrees. Now we have lists of 3 angle measurements, and we're going to check and see if these make a triangle. You can pause the video here and add these up and see if they equal exactly 180 degrees. So when we add together our first 3 angles there in number 1, we get exactly 180 degrees, so yes, that would make a triangle. In number 2, when we add them together, we also get 180 degrees exactly, so we're good for a triangle there. In number 3, when we add those together, we end up with 190 degrees, so we cannot make a triangle with that. That's too big. And then for number 4, when we add those up, we get 170 degrees, so that would not make a triangle because our angles are too small. Our lines wouldn't quite make that full triangle. The last thing we're talking about today is called the triangle inequality theorem, and instead of talking about the angles that make up a triangle, it talks about the sides. And the important thing to know about the sides of our triangle in this theorem is that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. And if that makes a lot of sense, because if I have 2 sides that are smaller, then what would end up happening on my triangle, say I had A here and I had 2 shorter sides, when I'd go to try to reach them, they wouldn't quite reach across. And if they were exactly the same length as that longer side there, A, then all that they would end up doing is meeting somewhere in the middle there and just making a line on top of a line, not a triangle. So 2 sides must be larger than the third. Now you could sit there and do 3 calculations whenever you have 3 lengths to see if they would make a triangle. But there's a shorter way. As long as we can add up the 2 smallest sides and have them be larger than the largest side, then we already know that if we do the largest number plus something smaller, it's going to still be larger than a smaller number. So save yourself some work. And for the triangle inequality theorem, even though you should know that any pairs of sides should be longer than the third, check by adding your smallest together and see if it's greater than the largest. So you can pause the video here and try to add up your smallest sides and see if they're longer than the longest side and therefore would make a triangle. So in number 1, when we go to add these up, we have 4 plus 5 and they would have to be greater than 7 to make a triangle. And in this case, 9 is greater than 7, so yes, those 3 sides would make a triangle. In number 2, we would have to see if 3 plus 2 is greater than 6. And 2 and 3 make 5, so that's not greater than 6, so no, those 3 sides would not make a triangle. The 2 and 3 sides wouldn't quite be able to reach each other as they're connected to either side of that 6. In number 3, the 2 smallest sides are 2 and 4, so we could see if those added together get us a number greater than 5. And they do, they give us 6, so those would make a triangle. And now for our last one, we have 2 8s and a 2. So already I can see here I've got 2 numbers that are the same, and if I'm using my shortcut, then I just need to add together my smallest side, so I'll just pick one of the 8s to be the smallest. And obviously anything plus 8 is going to be greater than 8 as long as it's a positive number. So that would make a triangle for us. What does this video make you wonder about determining conditions that make a triangle, whether with their angles or with their sides? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learn from your failures, then you succeeded.